Okay, new video so you don't get too boring or too bored. So here's the block. It's got the bearings in it again. Those are my measurements that I did the other day, but I'm going to do it a little bit different. I'm going to zero out the bore gauge on the micrometer, or I'm going to take the micrometer. I'm going to measure the journal, each of the main journals. I'm going to do one. I'm going to go put it in the vise over here. And then I'm going to zero out the dial gauge, the bore dial gauge, onto that for that journal. And then let's see how close my numbers are from yesterday, just to kind of do another thing. Kind of learning this stuff. I'm getting slowly good at it. But it's not that easy. You think just getting a device and measuring is simple piss, but it's not. You run into all kinds of problems. So all you guys who do this professionally, you guys are badass. Because it's so you got a lot of learning to do. So I'll do that, and then I'll stick the bore gauge down here. I'll measure each of the bearings and journals, and we'll go for there. And hopefully I can get this done today. So you can see my dial bore gauge here. This is a Kinex. It's all Czech brand stuff. It's supposed to be pretty good. And if you look at my other videos, the previous one where I said that the bore gauge was off, was not calibrated. Well, actually it was calibrated. It was just because I'm an idiot and I don't know how to use a bore gauge. So maybe there was some argument in there that it wasn't accurate, but anyway, so they kind of showed us how to properly use it, and whatever, it works. So if you're going to do this on your own, if there's someone that gives classes on it or a machine shop and they're good at it, have them give you a class on how to read it and how to the different ways to measure stuff. That's definitely worth it. So there's the dial gauge. It's accurate to 0.00, I think it's 0.0001. Alright, so we have 0.001 millimeters. You can see it there. Here's the digital caliper, which is I think to 0.01, which is not that accurate. It's good for testing, getting quick measurements, but don't use them for blueprinting. The internal micrometer, these things are expensive. I made my buddy get them. I said, "You're building engines. He's got engines all over the place. You're going to do this right, get the right tools." So he spunked the money on the tools. So there's that. That's for the rods. Sometimes you can get a T gauge instead of this kind of special gauge here. It kind of goes T's on each side, which I didn't see that here, so I'm not sure. This one's different. It's a little bit different. It's got the measuring the tool there. And then of course the micrometer. This is the best thing to get. Stay away from digital stuff if you can. Digital stuff is generally not as accurate. If you look in the catalogs for a lot of these, you'll see that you'll get the accuracy. This is to 0.001. 0.01. Oh, this was the 0.001. Son of a bitch. Maybe that's my problem. Anyway, so I'll have to go double check that now. Get the ones that are more accurate, 0.001 if you can. Those will be a lifesaver, but look at the accuracy that they have as well. There's lots of them that have different accuracies, so you might get down to 60 millimeter, for example, but it might be off by 0.04 or something. So that can make some difference when you're getting down here onto the doing clearances. So just keep that in mind. Anyway, so I'll see what I can do here today, and then I'll do a final video if there's a block put together. All right, thanks.